In today's lecture, we want to talk about alcohols, which are CNS stimulants. So we are covering these alcohols under CNS pharmacology to see how alcohols can stimulate the central nervous system. So we want to see three categories of alcohols where we are going to discuss in this video. We're going to discuss about ethyl alcohol. It is what we call ethyl alcohol, or commonly known as ethanol. We're going to discuss about ethanol and how it stimulates the CNS. Then we are going to talk about methanol. And this methanol is known as rubbing alcohol or wood. You can call it rubbing alcohol or wood alcohol. Then lastly, we shall talk about ethylene glycol in this lecture. So these are the three types of alcohols we are going to discuss for a couple of few minutes, showing clearly the metabolic pathway. We are going to discuss about the active metabolite, the side effects, and the antidote used in each type of alcohol. And we are going to begin with ethanol. Let's begin with ethanol, which we are calling ethyl alcohol. So this ethanol is the commonly used alcohol, and it causes addiction, whereby when ethanol is taken orally, majorly it is taken by oral route, and after being taken orally it is absorbed by simple diffusion, and its absorption is enhanced on empty stomach. When you take it on empty stomach, it is easily absorbed compared to taking it when you have taken food. So presence of food in the stomach slows absorption of alcohol, whereas when the stomach is empty, it is easily absorbed. And still we are going to see on absorption of alcohol, it is easily absorbed in women. It is easily absorbed in women or in females compared to men. So that's why you see when we are taking alcohol, females tend to become drunk faster compared to men because they have much lipid content in their body. So alcohol is absorbed faster in females. That is a very, very big thing to note. And after being absorbed and reaches in the liver, we are going to see in the liver, when it reaches in the liver, it undergoes biotransformation, whereby ethanol is metabolized to acetaldehyde, then it is also reduced to acetic acid. And we shall see that acetic acid is the active or a toxic metabolite. And this one involves coenzyme NAD, whereby NAD plus is converted to NADH in the presence of, and whenever I say NAD, I think of a dehydrogenase, and this is alcohol dehydrogenase enzyme. So alcohol dehydrogenase enzyme catalyzes the oxidation of ethanol to acetaldehyde, and this acetaldehyde is oxidized to acetic acid. So we are seeing another presence of NAD plus being reduced to NADH. Then the acetaldehyde is oxidized to acetic acid by an enzyme known as acetaldehyde dehydrogenase. Dehydrogenase enzymes are named according to the substrate they catalyze. And these processes, this metabolism of alcohol occurs in the liver, and after being metabolized, we are saying acetic acid is the toxic metabolite. It is the one that brings about toxic effects of ethanol. Maybe another thing I have not told you about absorption, that ethanol also crosses the brain-blood barrier. So it crosses the CNS and it can bring effects of central nervous system like depression when taken in larger dose. It can bring about memory impairment and the loss of balance. Loss of balance can bring about slurred speech. That is when taken in higher dose because it has ability to cross the CNS. So it affects the impairment or the judgment or the cognitive part of an individual after being intoxicated due to accumulation of acetic acid, which is the toxic metabolite. And this acetic acid formed, it can even be converted, it can undergo Krebs cycle. This one can undergo Krebs cycle where it can produce water plus carbon dioxide. This is ethanol. So whenever we want to treat someone who have undergone withdrawal syndromes, so we can target by inhibiting this enzyme acetaldehyde dehydrogenase or alcohol dehydrogenase. But we shall see after discussing different alcohols where we can see the management in case of intoxication. So after here discussing ethanol, we can now go to the second one, which is methanol. So this was the first one. The second alcohol we can discuss is methanol. Methanol, which we are calling wood or rubbing alcohol. And this ethanol, for it is known to cause retinopathy, or what we call blindness. When you taken in higher quantities, it can bring about total blindness. And when the absorption is the same, it also crosses the blood-brain barrier. And when it reaches in the liver, methanol is, which we are calling rubbing alcohol, it is oxidized to formaldehyde. Formaldehyde is oxidized to formaldehyde by enzyme alcohol dehydrogenase in the presence of NAD plus to form NADH. And this formaldehyde formed is oxidized to formic acid. It is oxidized to formic acid in the presence of NAD plus forming NADH reduced in the presence of formaldehyde dehydrogenase. So the enzyme here is formaldehyde dehydrogenase enzyme that catalyzes oxidation of formaldehyde to formic acid, and this formic acid is the toxic metabolite. So the toxic metabolite of methanol is formic acid, and this toxic metabolite, it is the one that goes to the eyes, and when it goes to the eyes, it can cause blurred vision at the first, then it can lead to blindness. So ethanol is the peculiar cause of retinopathy or blindness when taken in higher dose due to accumulation of formic acid in the body. So when the formic acid levels go high, they affect the retina of the eye, leading to blurred vision, and when it continues, it results into total blindness. That is methanol. So after looking at this, we can now look at the last one, which is ethylene glycol. And ethylene glycol is the third one we are going to discuss in this session. This one also, the pharmacokinetic is the same. It is absorbed by simple diffusion. It is slowed, its absorption is slowed by presence of food in the stomach. and we're going to see it can also cross the blood-brain barrier. But what we want to see that this ethylene glycol, in the presence of alcohol dehydrogenase, it is oxidized to glycoaldehyde. So when we have ethylene glycol and reaches in the liver, it is oxidized to glycoaldehyde. And this glycoaldehyde, this is in the presence of alcohol dehydrogenase, in the presence of NAD. And after forming glycoaldehyde, it is then reduced, or it is oxidized to a compound known as glycolate. This one is metabolized, it is oxidized further to glycolate. And this glycolate, this one occurs in presence of glycoaldehyde dehydrogenase, or even we can call it aldehyde dehydrogenase enzyme in the presence of NAD. So this glycolate formed can be further oxidized to produce oxalic acid, and this oxalic acid produced can cause renal. So this one can even be metabolized further to oxalic acid. And this oxalic acid, together with the glycolate, they lead to formation of calcium oxalates in the kidney, and accumulation of calcium oxalates in the kidney can cause kidney stones, and this one can result into renal failure. So the peculiar intoxication, so we are seeing the toxic metabolite can be glycolate or oxalic acid. So oxalic acid accumulation or glycolate accumulation is the toxic, these two are the toxic metabolite of ethylene glycol. And we have seen the major effect of ethylene glycol is renal failure. The major effect of methanol is blindness, or what we are calling retinopathy. Retinopathy. And this retinopathy is even accompanied with the Wernicke-Korsakoff's syndrome. It can also result into Wernicke-Korsakoff's syndrome. And this syndrome is characterized by failure to for dilatation of the eye. That is what we call Wernicke-Korsakoff's syndrome. Then we have seen ethanol for it. It is broad spectrum. So we are going to see the effects and how we can treat the effects. So we want to see, in the case of intoxication, what are the toxic effects of these alcohols. And among the toxic effects we have seen, we have retinopathy as number one, which we can call blindness. We have renal failure, another effect of alcohols. Then we can talk about effects on the CNS, which we have seen depression when taken in higher dose, result into CNS depression, memory impairment. We have seen memory loss, with loss of judgment. We can see loss of balance. This is when taken in high dose. Then it can also result into other effects on the respiratory system. It is the alcohols are known to cause respiratory depletion, and this is the leading cause. It can lead to hypothermia due to loss of, because it causes vasodilatation. You can see it can lead to hypoglycemia in diabetic patients. Hypoglycemia is also another effect of alcohol, and so forth. There are many causes of this alcohol intoxication. It can even lead to, it is teratogenic when taken to mothers who are pregnant. It can cause fetal alcohol syndrome, fetal alcohol syndrome. And this fetal alcohol syndrome, it is characterized by mental retardation in children. And we are saying retinopathy is a peculiar of methanol, whereas renal failure is a peculiar of ethylene glycol, is the one that causes that. Together with this one can cause retinopathy or Wernicke-Korsakoff syndrome. Then CNS depression is all because they cross the blood-brain barrier. All of them can lead to respiratory depletion, and many people with respiratory depression causes acidosis, that is respiratory acidosis, then coma, and if not attended to, it can lead to death. So we're going to see how can we manage these side effects, or which drugs can we use to treat these toxic effects of alcohol. For example, I'm going to put them here. We're going to see some antidotes. I want to see which antidotes are used to treat. So what are the antidotes used? But before using specific antidotes, the first thing is always checking for electrolyte balance. When you get someone who has been intoxicated with alcohol, you check for electrolyte, you check for body vitals like temperature and glucose levels, because we have seen it can cause hypothermia together with hypoglycemia. So before giving someone D5, you have to check for glucose levels before you intervene. Now those are managing of the side effects. Then after that, we can give specific antidotes. And these antidotes which we can give commonly used, we have fomepizole. Fomepizole is the commonly used drug. Then we can use naltrexone, can also be used. We can use disulfiram. Disulfiram is another drug we can utilize, and this one is responsible for alcohol withdrawal. In case someone is willing to leave alcohol, we can give them disulfiram. And this one, it brings about disulfiram-like symptoms, which include nausea, vomiting, headache. And when someone, and whenever takes alcohol and have these symptoms, he becomes or feels tired of alcohol and wants to leave it. That's why we give disulfiram. For it, it brings about disulfiram-like symptoms, which is nausea, vomiting, and headache, which can cause someone to hate alcohol and immediately can leave it. Then fomepizole, for it, when given, it targets and inhibits alcohol. So fomepizole comes and inhibits alcohol dehydrogenase in each pathway. And when it inhibits alcohol dehydrogenase, meaning we cannot form toxic metabolites of alcohols. So that is its mechanism of action, whereby it acts by inhibiting alcohol dehydrogenase enzyme responsible for metabolism of different alcohols. So whenever given, meaning we cannot form toxic metabolite. Then there are other opioids. Opioids can be used, and these opioids are also used in people who are suffering from withdrawal syndrome, like tremors and so forth. So we can give opioids for treating withdrawal syndrome, like tremors. These ones we can utilize opioids. Then we can use even NMDA antagonist, that is N-methyl D-aspartate receptor antagonist, like topiramate. We can utilize it. We can utilize the compressate. So these ones are used to treat alcohol craving. Whenever someone craves for alcohol or he feels he cannot sleep without alcohol, we can give this MDA like topiramate and acomprosate to treat alcohol craving. So this is what we do. So among the management of alcohol intoxication, don't forget fomepizole, which acts by inhibiting alcohol dehydrogenase. Then naltrexone, then we have sindasulfiram to people who are willing to, they are willing or they have motivation to live, but they are failing. You can give them disulfiram. Then opioids, then MDAs are used for treating alcohol craving. But at the beginning, we told you we also treat symptoms. We look for the temperature, we measure temperature, blood sugar levels because of causing hypoglycemia, and also do electrolytes because of whereby respiratory depression can bring about acidosis. So meaning we can even give bicarbonate, sodium bicarbonate to treat that. Thank you for learning with us from the beginning until the end. We're always privileged and honored to have you on our channel. Thank you so much.